When we talk about trigonometric ratios, we talk about sine, cosine, and tangent. You only use these three trig ratios when you're dealing with right angle triangles. You also use the theorem of Pythagoras when you are dealing with them. Let's just put an angle of theta right there. Angle A, B, and C. Angle A in this case is theta. The side that's facing angle A, or that's opposite to this angle, is called the opposite side. Or in simple terms, y. The side that's next to it is called the adjacent side. Or in simple terms, x. The other side that's next to it, but it's facing or is opposite to the 90-degree angle, is called the hypotenuse side, or in simple terms, r. The trig ratio sine is equal to opposite side over hypotenuse side, or in simple terms, y over r. The trig ratio cosine is equal to the adjacent side over the hypotenuse side, or in simple terms, x over r. The last trig ratio, which is tangent, is equal to the opposite side over the adjacent side, or in simple terms, y over x. The term SOH CAH TOA summarizes what I just said, the entire thing. So right here is sine opposite hypotenuse, meaning sine of a certain angle is equal to opposite over hypotenuse. CAH is cosine adjacent hypotenuse, meaning cosine of a certain angle is equal to adjacent over hypotenuse. TOA is tangent opposite adjacent, meaning tangent of a certain angle is equal to opposite over adjacent. The term SOH CAH TOA only works on right-angled triangles. Now, on this right-angled triangle, when we focus on sine angle A, we realize that sine angle A is still the same as sine angle theta, because angle A and angle theta are the same thing in this example. Since we're focusing on angle theta, we have to make sure that this right angle triangle is in a way that the side adjacent to the angle theta is horizontal and the side opposite to it is vertical. Let me repeat that again. Since we're focusing on angle theta, we have to make sure that this right angle triangle, the right angle triangle ABC, is in a way that the side adjacent to angle theta, which is this side right here, is horizontal and the side opposite to it is vertical. Now we can see sine theta is equal to the opposite side, which is this side right here, over the hypotenuse side, which is this side right here. That means sine theta is equal to BC, side BC over side AB. Why? Because BC is already Y and then AB is already R. Now when we focus on sine angle B, we have to make sure that this right angle triangle is in a way that the side adjacent to angle B, the side adjacent to angle B, is horizontal and the side opposite to angle B is vertical. It should be something like this. Now we can definitely see that sine angle B is equal to opposite, which is AC, over the hypotenuse side, which is AB. The side that's adjacent to angle theta, which is AC, is the opposite side to angle B. Here it is. That means opposite sides and adjacent sides change when we focus on different angles, but the hypotenuse side always stays the same. Now let's focus on how to get the value of an angle. Let's just say we were given this information and we're required to get the value of theta. So when we look for sine theta, we realize that it's equal to 1 over 2. On your calculator, always remember this trick. You're going to use it in the 11th grade and the 12th grade. Make sure it's written D, not R. After, press sine. We want to get rid of sine and get the value of theta. So you're going to press the arrow that takes you to the left, then press shift and press sine again. You should have something like this on your calculator. Just remember this, all right? Let's do the same thing for sine right here. It's going to be sine arc. We call this sine arc. We're going to put in sine theta is equal to whatever you do on the left hand side, you also do on the right hand side. This sine right here is the one that we place on the calculator, and sine arc is also the one that we place on the calculator. The only thing that we don't have on the calculator is theta. But since theta is an angle, we can give it any number. So right here is where we're going to put in theta. So let's just put in 0 degrees. Let's just put in 0. And then let's close the bracket. Right? We already can see that the answer is 0, right? Whatever angle we're going to fill in for theta, in this case, I'm trying to show you something. Whatever angle we're going to fill in for theta has to give us that angle, but it should be between 0 degrees and 90 degrees. If it goes beyond 90 degrees, your calculator is going to reduce it automatically. Since you placed in 0, we still get 0. Let's place 45. We still have to get 45. We get 45, right? How about 30? We get 30. Okay, let's put in 89. We get 89. Let's place in 90. We get 90. Let's press in 91. I told you that your calculator was going to reduce it automatically. Let's place in 135. It's going to be 45. Let's place in another special angle, 120. We have to get 60. Exactly. So your calculator reduces it automatically. We'll get to the reduction formula and everything like that. Right now, let's just focus on knowing what numbers to fill in for theta. Theta right here can represent any angle. And in the end, we're still going to get what? We're still going to get theta. This is for the people in the 10th grade. When you get to the 11th grade and the 12th grade, you're going to realize that theta now becomes the reference angle. Sine arc into sine theta. Sine theta from the beginning was equal to 1 over 2. So since sine theta is right here, that means when we have sine arc 2, this right here has to be equal to sine theta. 1 over 2 has to be equal to sine theta. So since when we do sine arc into sine gives us an angle which is theta, then this right here has to give us an angle too. If when we do sine arc into sine gives us theta, when we do sine arc into a ratio, it has to give us an angle. And the angle that we're getting right here is supposed to be 30 degrees. So what happened exactly? This is my trick. I don't know if this is valid or not. Just be like sine canceled sine. And we only got theta. So right here, since 1 over 2 is already a trig ratio, the entire thing has to be equal to a certain angle. So theta is equal to 30 degrees. That's how you find an angle. Now let's look for sine B and cos B. Let's look for cos theta. You can pause the video to do these on your own. Sine B is supposed to be equal to square root of 3 over 2, right? That's for sine B. Cos B is going to be 1 over 2. Why? Because B is adjacent to this side, and it's an adjacent side over the hypotenuse side, which is still 1 over 2. Cos theta gives us square root of 3 over 2. Do you see something right here? We can see that sine theta is equal to cos B, and sine B is equal to cos theta. Why? When we try to find angle B, we're going to figure out that angle B is equal to 90 degrees minus theta. If we had to look for all the angles in that triangle, we're going to figure out that angle B is equal to 90 degrees minus theta. Why? Because it's 180 minus this 90 minus theta. So 180 minus 90, that's already 90, right? And then we already have 90 degrees minus theta. So angle B has to be equal to 90 degrees minus theta. So we can definitely see that sine theta is equal to cos 90 degrees minus theta. And sine 90 degrees minus theta is equal to cos theta. This right here is called co-ratio or co-functions. If we were to look for tangent B and look for tangent A, we're going to figure out that tangent B is equal to square root of 3 over 1. Why? Because it's opposite side over adjacent side, which is square root of 3 over 1. And then for tangent A, it was going to be opposite side, which is 1 over square root of 3. What happened here? So what happened here is tangent A is equal to 1 over tangent B. Why are we saying that? Because if you put square root of 3 where we see tangent B, that will be square root of 3, right? what does it make? It gives us tangent A. If we put in tangent B, obviously square root of 3 over 1 is equal to square root of 3, right? So where we see tangent B and put in square root of 3, it will give us tangent A. So that's 1 over square root of 3. So that means tangent theta is equal to 1 over tangent 90 degrees minus theta. So that was trigonometry for beginners. If this video really helped you a lot, like this video and subscribe to the channel for more videos on trigonometry. Stay tuned.